Lesson 7.7 is kind of like another extension of lesson 7.6, factoring special quadratics. So an example of a special quadratic is like x squared minus 25. Or we have another kind of special quadratic. There's two here. The other one is m squared minus 2m plus 1. Okay. Now this one, well, we can use our old strategies for these, but this one, it's only two terms. It's only a binomial. But I can make it look more like a typical quadratic by adding in a 0x, because 0x has no value, so I'm allowed to add 0x somewhere in the middle of the problem. All right, so we have strategies for solving these. Lesson 7.7 is just about some patterns that can make them faster if you identify the patterns. First pattern, difference of squares. So what does difference of squares mean? That means difference, subtraction, and then we have two perfect squares. So if you notice over here, it's a squared and b squared, but over here, it's just a and b without exponents. Okay, so these are the square roots of those. So let's look at something that is a perfect square, a difference of squares, x squared minus 25 like we just had before. So we have the subtraction, we've got a difference. What else are we looking for? A squared. Well, what if I just trade the a out for the x? X squared has to be a perfect square because x squared means x times x. So the square root of x squared means I would just use x for the a. And then over here, this is b. Square root of 25 is 5. So 5 is my b. So I'm going to fill this in as x plus 5 and x minus 5. And it's only because we identify perfect squares with a difference in between. Okay, now let's do this our normal factoring way, where I rewrite it as x squared plus 0x minus 25. So I'm doing 1 times negative 25 equals negative 25. And then I try to find 0, which is going to be negative 5 and positive 5. Fill out my box. I've got x squared. I've got negative 5x and 5x. And I've got negative 25. X squared is easy. These both have to be just 1x. X times 5 gets me 5x. X times negative 5 gets me negative 5x. Check our last box. Negative 5 times 5 is negative 25. Looks like it works out. And once again, I get x plus 5, x minus 5. So it does work. This is just a pattern. Difference of squares is a pattern. When an equation looks like this, the factored form is always going to look like this. It's just a pattern as a result of doing a lot of quadratics that look like this. Our other pattern that's honestly a little harder to identify is a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. So this one I don't blame you if you don't directly use, but let's try one. I'll actually try two. We'll do an addition one first. N squared plus 8n plus 16. Okay, if I factor this normally, I look for factors of 16 that add to 8. All right, I would come across 4 and 4. So I'd fill out my box. I'd have n squared, 16, and 4n, 4n. The n squared is easy. They both just have to be n. N times 4 is 4n. N times 4 again is 4n. 4 times 4 is 16. So I get n plus 4 times n plus 4. That is what this means. I can actually write this because it's the same parentheses multiplied twice. That's what exponents mean. That's where that comes from. This means n plus 4 squared. That means I got two of the same factor for my answer. So let's look at the pattern and see why that works. All right, n squared is a perfect square. So that means n, square root of n squared is n, would be my a value. This is supposed to be b squared. 16 is a perfect square. So 4 is my b value. And then we have to check the middle. 2 times a times b. So 2 times n times 4. Well, the 2 times the 4 is 8, and then there's just an n. So we get 8n in the middle. And that's how we check this. We try 2 times a times b, and if we get that, it's a perfect square trinomial. Now, I can still factor this if I have like a 10 here, because 16 has factors of 2 and 8, and then this doesn't work anymore, and it's not a perfect square trinomial. That's what makes it harder to identify, is we have to check that middle number and see if it worked out. So this one I don't blame you if you don't use as often, and you just factor it like normal, because otherwise you're trusting your mental math and may make a mistake. So the difference of squares is way easier to identify. The perfect square ones might give you a little more of a challenge. So let's look at another one that's supposed to be subtraction, and let's check if the pattern's going to work first. So we got something interesting going on here. Is this a perfect square? We have to check both the number and the variable. We know x squared is a perfect square because we've seen that a couple times this video already. But the square root of 4 is 2, so that also works. So square root of 4 is 2. Square root of x squared is x. So this is a perfect square. So far we're on the right track. Is 9 a perfect square? Yes, it is. 9 is 3 times 3. So that's my b value. And then we check 2 times a, which is 2x, times 3. So let's multiply all the numbers together. 2 times 2 is 4. 4 times 3 is 12. We're good. The only difference is because this one has a minus sign, my factors are both going to be a minus b. So my result is a, 2x, minus b, 3 squared. If I did this with my normal factoring method, we would get that same answer. Hopefully you trust me. 4 times 9 is 36. So we're looking for factors that'll get us negative 12. All right, we have to go with two negative numbers. Negative 6 and negative 6 will get us negative 12. Fill out the box. We've got negative 6x, negative 6x, 4x squared, 9. So we can start somewhere and find the greatest common factor. Let's look here. We know we're going to have an x, but what's something I can divide out? I can divide out a 2, and since they're not both negative, I'm going to divide out a positive 2. If they were both negative, I'd divide out a negative 2. Heck, if they were both negative, I'd probably divide out a negative at the start of the problem. So 2x, this also has to be 2x then, 2 times 2 and x times x. 2x times a negative 3 would get negative 6, and 2x times negative 3 would get this negative 6. Negative 3 times negative 3 is positive 9. And we're right back there. So any way you do it, it works out. The patterns can save you time, but this one takes a little more work. So at least learn the difference of squares. It's the best one to remember by far. All right, that's really it for the video. It's just some patterns that might save you time, but everything we did in lesson 7.6 still works here. Same factoring method.